Welcome back, students, to How to Manage Technology Projects by KP LAMA Education. We're now on video 3 of the 6 videos in this lecture series. In the first lecture we talked about what is a technology development project and why is it different to other projects. In the second video we talked about what are the different processes of managing technology development projects. And today, in this video, we're going to be talking about ensuring you pick the right projects and why. So, ensuring you pick the right projects. Making the resource commitment decisions for technology development projects, especially in the early stages, is problematic for many companies. Clearly, traditional tools such as financial analysis and profit criteria are not too useful. In TD projects with much undefined, the level of uncertainty is so great that numerical estimates of expected sales, costs, investment and profits are likely to be grossly in error. There exist many uncertainties in the typical TD project, but the one thing you can be certain about is that your numbers are always wrong. Indeed, there is a considerable evidence that businesses that rely strictly on financial tools and criteria to select projects end up with the lowest value development portfolios. As one executive declared, in noting the deficiencies of his company's sophisticated financial analysis methods for project selection, "It's like trying to measure a soft banana with a micrometer." Our evaluation tools assume a level of precision far beyond the quality of the data available. Not surprisingly, this executive's financial evaluation tool tended to favour predictable and close-to-home projects at the expense of technology development projects. Best performers adopt a combination of evaluation techniques and criteria for making go-kill decisions on TD projects. The research suggests that no one method works best across the board and can do it all. First, we should consider using a scorecard approach, which looks at multiple facets of a TD project, from strategic to technical issues. Note that this TD scorecard is different than the one that should be used for new projects. A best practice model for Gate 3 for TD projects is shown later in this lecture. Scorecards are highly rated by users as a solid decision-making method and tend to yield more efficient and more effective go-kill choices, higher value projects, and a portfolio of strategically aligned projects. In the scorecard approach, the project in question is presented by the project team at each gate meeting, shown in yesterday's lecture, and a thorough and facilitated gate discussion ensues. Next, the gatekeepers score the project on a 0 to 10 scales. The resulting scores are then combined to yield an overall project attractiveness score. This scoring exercise and final score become key inputs to the go-kill decision. Although many users of this approach claim that it is the process, a senior decision-making group going through a set of key questions, debating their scores and reaching closure on each, that provides the real value, and not so much the final score itself. Although the sample scorecard shown there is for Gate 3, note that most businesses use the same high-level criteria from gate to gate for consistency, with the detailed or sub-questions becoming progressively tougher at successive gates. Businesses that rely strictly on financial tools end up with the lowest value development portfolios. To summarise this, in addition to a gate scorecard, consider the use of success criteria as employed by the company Procter & Gamble. Here, the project team declares what they hope to achieve in order for the project to be considered a success. Success criteria for TD projects: what they hope to achieve in order for include the achievement of certain technical results, example being positive lab test results by a given date, attaining a certain technical performance improvement, i.e. a certain level of absorption in a new fibre technology, or the expected sales potential to be generated by the new technology, i.e. the size of the market that this technology may see potential in, if successful. Success criteria are declared relatively early in the project, and on this basis, gatekeepers approve the project at the early gates. These criteria are reviewed and updated at each successive gate. If the project falls short of these success criteria at the next gate, it may be killed. For example, if certain technical results were not achieved by a given date or gate, the use of a success criteria allows the project team to develop customized criteria to suit their project. It forces the team to submit realistic rather than grandiose expectations, and it creates accountability for the project team, something to measure that team against. So here we have the scorecard with the 0 to 10 scale to rate and prioritise TD projects. So you've got number 1, the business strategy fit, congruence and impact. Score of 0, only peripheral fit with our business strategy, minimal impact, no noticeable harm if the project is dropped. Score 10 out of 10, strong fit with several key elements of strategy. This business future depends on this project. So I've shown you how easy it is to compare if it was easily dropped, it will have no impact on the company, or if it is extremely valuable to the company very early on in the decision. Second score, strategic leverage, proprietary position, platform for growth, durability, which is technical and marketing, and synergy with corporate units, i.e. the base technology that the company uses. With a score of 0, it is easily copied, no protection, dead end, one of a kind, one off, no distinctive advantage, quickly leapfrogged by others, and it's limited to a single business unit. If I had a 10 out of 10 score, position protected through patents, trade secrets, or a raw material access, etc. etc. Opens up many new product possibilities, long life cycle with opportunity for incremental spin-offs. Could be applied widely across the corporation. Scorecard. Score 3. Probability of technical success. Technical gap, project complexity, technology skill base, availability of people and facilities. For a score of 0 on the technical gap, large gap between solution and current practice, must invent new science. A score of 0 for project complexity, difficult to envision the solution, many hurdles along the way. Score 0 for technology skill base, technology new to company, almost no skill internally. Score of 0 for availability, must hire and build. Score out of 10 for technical gap, incremental improvement, easy to do, existing science. For project complexity, 10 out of 10 score, can already see a solution, straightforward to do. Technology skill base, 10 out of 10, technology widely practiced within the company. Availability of people and facilities, 10 out of 10, people and facilities immediately available. The fourth score, probability of commercial success in the case of a TD project with potential for new products. Market need, market maturity, competitive intensity, commercial applications, development skills, commercial assumptions, regulatory and political impact. Now a 0 score for market need, extensive market development required, no apparent market exists at present, whilst a 10 out of 10 score for market need, product immediately responsive to a customer need, a large market exists. A 0 score for market maturity, declining markets, or a 10 out of 10 score is the exact opposite, rapid growth markets. A 0 score for competitive intensity, high, many tough competitors in this field. A 10 out of 10 score, low, few competitors, weak competition. commercial applications with a 0 score is new to the company. We have no or few commercial application skills here, must develop. Whereas a 10 score for for development skills is commercial application skills and people already in place in the company. A 0 score for commercial assumptions, low probability of occurring, very speculative assumptions. A 10 out of 10 score is highly predictable assumptions, high probability of occurring. A 0 score for regulatory and political impact is negative. 10 out of 10 score is positive impact on a high profile issue. Score 5. Reward. Contribution to profitability, payback period, time to commercial startup. A 0 score for contribution to profitability, rough estimate, less than 10 million cumulative over 5 years. 10 out of 10 score, rough estimate, more than 250 million. A 0 score for payback period, rough estimate, greater than 10 years. 10 out of 10 score, rough estimate, less than 3 years. Time to commercial startup, greater than 7. 10 out of 10 score, less than 1. Now, as a basic scorecard, it's fairly obvious. It's quite straightforward to understand what gives it a 10 out of 10 score and what would give it a 0 score. Now, the next part is ensuring resources are in place. How does one ensure that resources will be available to undertake TD projects, especially with today's emphasis on short-term projects? Management and a number of companies have recognised that significant resources have shifted from venturesome projects to small, lower impact efforts. In order to correct this imbalance, they employ strategic buckets as a tool to ensure that the right mix of projects, short-term versus longer-term, or TD projects, in their portfolios. Strategic buckets is a portfolio management method that defines where management desires the development dollars to go, broken down by project type, market, geography, or product area. Strategic buckets is based on the notion that strategy becomes real when you start spending money, thus translating strategy from theory to reality. It's about making decisions on where the resources should be spent. Strategic buckets, for example. In the example to come later in the lecture, management begins with the business strategy and then makes strategic choices about resource allocation. How many resources go to new products, or to improvements, or to technology developments? Now, here is the technology bucket. Resources are strategically allocated by project type into strategic buckets by senior management. So here we have the TD bucket in the table to the left, showing each of the projects: Genie, Monty, Coolflow, Pop-Up, Regatta, Slow Brew, and Widget 4. And each of the projects are ranked according to their gate score. And then they are placed into the relative bucket to ensure that they have the resources required to get them through the basic stages of the stage gate process, so that it is not killed outright at the start. With resource allocation now firmly established and driven by strategy, projects within each bucket are then ranked against one another to establish priorities. Note that projects in one bucket, such as technology developments, do not compete against those in another bucket, such as sales and marketing requests. If they did, in the short term, simple and inexpensive projects would always win out, as they do in many businesses. Instead, strategic buckets build firewalls between buckets, thus by earmarking specific amounts for technology developments, the portfolio becomes much more balanced. Note also the different criteria should be used to rate and select projects in each bucket. For example, the relatively qualitative criteria in the previous figure work well in order to rank projects in the TD bucket, but for modifications and improvements or sales requests, clearly financial criteria, profits, savings, or expected sales increase are the best way to rank these projects. Now, making sure your TD projects pay off. Technology developments are the engine of growth for many corporations and industries, providing the platforms for the next generation of new projects, of new products and new processes. With most companies facing constrained resources and having a short-term focus, it is imperative that such projects be managed more effectively than in the past so that they truly do achieve their promised results. Adopting a TD stage gate process using custom tailored go-kill scorecards and success criteria, and employing strategic buckets to ensure resource availability are but some of the approaches that leading companies are adopting to handle these vital TG products. Now that will mark the end of the third lecture. Don't worry, there's not any tutorials for this lecture either. However, next episode will be the first of the case study lectures, which we will be focusing on failed um, failed industry products, technology products by the Navy and the United States of America's government on the census. So join us for that. But if you have any questions concerning today's lecture, feel free to put your questions in the forum as you have done previously. Continue to read the book, the recommended reading, if you bought it or found the PDF to further understand this question. If you have any questions, we'll try and answer them as soon as possible in the forum. So until next time, I'll see you on the next episode.